before the voice better. Okay. Before we start the technical part, we want to work on some logistics. Today we need to finalize our group assignment and also pick the presentation date for your paper presentation. Let me. Xander and Yunlo, are you there?
Yes, Professor.
Yes, I'm here.
Great. Let me give you one document. Okay, later you should soon you will receive an email regarding this. But let me see. So we have a. Are you there in the shared doc? Yunlo and Sander, did you receive the? Okay, good. I saw you there. So basically, in the bright space assignment, you can. I think I have students submitted their group, so you just put them name there one by one. Maybe let's do this. So Sander, can you just put the name here, and Yunlo, you can do another one. That is to create the groups accordingly. In the bright space system. So do you know how to do that?
Sorry, Professor, I didn't get the email.
You should get it soon.
Okay.
Yeah, you're listing there, so you should get it. But never mind. So what you need to do is that go to the bright space, right? In the course admin, there is a groups. You just create the group. By adding students here. Yeah. Okay, so because later when we give some of the assignment that will be done in a group. So yeah, that is one. Okay, let's continue our technical part. And after the TA finish this one, we will come back so that I will talk about your paper presentation, and you need to also select the presentation date. Okay. Last time we stopped here, right? So this time let's continue. So this is the traditional storage architecture. Right. So it's like for each processor, it has its lower own L1 cache, and it may share with others the L2 cache. Right? And then it has a local DRAM, the main memory, and they can access a local disk or the SSD or they can go through the rack switch, right? Remember that for each rack, it's just a local box. You can, through the rack switch, access the memory, all the disks on the servers in the same rack. Of course, you can go through the data center switch, right, to access the memory and disk from the servers in the same data center, right? So you can say, here list the difference, right? If you do local one, you may have a, you may have a 16 gigabyte of memory. At the point here. Right. And it's very fast. And you can read with a very high bandwidth with a low latency. If you do disk, the disk is much larger, but it's slower. Flash is something in between. But if you do the local rack may have 80 servers, and that give you a much larger DRAM, memory, disk, and a flash drive. But the time here all added the network communication time, and the bandwidth now is all bounded by the rack switch. Of course, if you can afford a higher speed in the rack switch, you get better, but it's still much slower than your own DRAM. If you go to a cluster, the cluster may have 30 racks. In that sense, you can access to a huge amount of memory, 30 terabytes in this case. But the bandwidth is much smaller, right? And the latency also increased significantly. Similar, if you go to disk, it's really large, and the flash drive is something in between. This just give you some high-level idea of how it differs at a different level, and of course, whether you use the local own server or the local rack, or you go to the cluster. Right. So this just shows the difference, right? And as you go, you can see this one, the bandwidth basically keep dropping, and the latency, right, also have a tendency to increase, but after a while, it stays roughly this one, right? Because capacity trend is going up. Right. This is the one to compare, right? If you just have a traditional DRAM and disk, right, versus now you have a flash in the middle, right? You can say the DRAM latency very low, right? The bandwidth very high, right? But the cost is high. Versus disk, cost is very low, right? And bandwidth is also low, and the latency is high, right? And the flash is basically in the middle, right? Then it changed from the traditional 2 layers, right? The DRAM and the disk. Now you have 3 layers, right? For student, you may work on some kind of the paging algorithm, right? That is because the memory is limited. You need to decide what to keep in the memory, right? So that is originally just a 2-tier problem, but now you have 3 tiers, right? You can imagine the problem is that what do you want to put into the flash drive, and among this one, what do you want to put into the DRAM? Okay, power usage. Right. This is a very important problem now, right? But you can see in the old days how it looked like. Right? The CPUs, it take half, almost, right, of the total power usage, and the DRAM, 11% or 12%. Right? Disk similar, right? Network and others similar. And power, the cooling, you see these 2 parts combined is less than 1/4, right? So this is already a very good data center, right? Because as we know that the power overhead can easily become like 1/3 or half of the power usage. But you can also see from here, this one, the CPU is very powerful. This is one example. Demand. The traditional demand like a web look like this. There is a very strong diurnal pattern, 24 hours. And you can imagine, right? Nowadays, for example, LLM may look like similar. Previously, it's a Google search, but there is no major difference, because it's all human created, so that it's related to the diurnal pattern of a human being. Okay, this one is what we discussed about the demand, right? This is a it's a set of figures showing the demand. So from here you can see the job submission. Some of them, they have a clear diurnal and weekly pattern, and some of them may not be that clear. But if you look at the I/O, it's much harder, right? And similar for compute and the system utilization. So basically, you can see each row is a different application. So across applications, it's very different. And for Facebook, from 2009 to 2010, it's also very different. Right? Some workload, they have the diurnal or weekly pattern, while others it's hard to see, right? Like this one, it's a lot of a spike, right? This is very hard to manage. Tail performance, right? So this is something let me explain in more detail, because this is very important. So for this figure, the horizontal axis is how many servers you use. Like it can be one, right? Or it can be at the most 2,000. And the y-axis is a probability. The service latency is larger than 1 second. Right? And for Google search, right? So if it's larger than 1 second, you will realize, you will feel the latency, right? So that's clearly not good. But of course, nowadays, right, for GPU calculation, the inference job, you can see this number of servers may be a little bit smaller, right? But the GPU also a large number. And the service latency, right? This one may be a little bit relaxed, right? So, but still you will see some kind of a phenomena like this. Okay, so there are 3 lines. The first line is that you will have the failure, right? Not just failure, you will have a kind of the slow server. The server basically responds with a delay larger than 1 second. So the blue dashed line means that the probability is 1 in 100. And the red line is 1 in 1,000. And the green line is 1 in 10,000. Right? Of course, this one probably is more realistic, right? And if you make it more and more reliable, actually it's more expensive. And it's more challenging to manage. But the problem is that you say, if you have one, the server, just 1% of your server may have this high latency. The result you get is that the service, the latency larger than 1 second, the probability quickly goes to almost 1. Right? You don't need a lot of servers to use in parallel that you go to like with 63% of the time you have the latency very large, right? Means that kind of you have the failure. Right? So, and this one probably just 50 servers also, right? But the 50 servers, it's just a small level of parallelization, right? Oh, if you
Sorry,
say,
Professor,
go ahead.
quick question. Does this, when you're talking about latency, you're talking about latency between the servers, correct?
No, it's the latency. Okay, think about this like this. Good question. Let me explain that first. So basically, you can imagine you have a service, right? But you put the service out to multiple servers. So total, you have n of them, and this is the number of servers. And then each server may take some time to respond. Once you get the response, for example, for the ICE server, your response time is Ri. But for the service as a whole, the service response time R will be the max over I of this Ri. Because you need to wait until last one gave you before you can send it back. Right?
That makes sense. Thank you.
1 in a second basically means that with 1% of probability, this Ri is larger than 1 second. And the service latency is a probability this R, capital R, is larger than 1 second. Right? So this is because you need to wait for the last result to come, right? In most cases. Right? So that's why even you just have a small level of parallelization and fairly okay, right? Because 1% of server has some larger delay, it's not a big problem, not a bad situation, right? Actually, it may not be very easy to achieve. But using this, you already get a very high probability your service will be not very good, right? With a high delay. Even if you make it 1 in 1,000, basically 0.1% of the chance for server to give larger delay, this line still goes very fast. Right? Say if you have 500, then with a 40% probability, your service latency is larger than 1 second. This one, right? If you make it a 1 in 10,000, right? This is really, really hard to get, right? Because the server may have all sorts of reasons to give you a larger delay. But if you get the probability of 2,000 server, you get 2,000 server, the probability is 18%. It's still not negligible, significant actually, right? If you have a service, almost 1 in 5, every 5 requests you get a one large delay, right? You probably will feel like it's very bad service. Right? So this highlight the challenge when you to provide the tail performance, right? Because the tail performance means that you need to wait for the last one, right? The tail to finish when you have a high level of parallelization. Right? Think about in data center or in future computing, the high level parallelization is probably will be the same, right? Whether it's a traditional search or the social network, right? Or the current large language models, right? So they all use a lot of servers. And the servers cannot be that reliable, right? Even you pay a lot by the enterprise level, for example, you pay from NVIDIA, right? NVIDIA, the server, especially with a lot of GPUs, still goes down, right, from time to time, right? But you can say, you definitely don't want your customer to wait for a long time, right? But that is the challenge here. So any question about this one? Okay, good. So for performance, I think this figure highlights the biggest challenge in data center performance management. Okay. But on the other side, another side note I can show you, want to talk to you is that, but if you want to do, this is the tail performance, right? So basically it's against you. But in some other cases, the tail performance help you, right? Can consider the problem, the situation is a VC. So this is a parallel computing versus venture capital. Right. So the second one is that you can imagine that in the venture capital, most of the company they invest fails. Right. But it's just 1% of the company who are successful actually bring the most of the return. Right. So that is another situation. Right. Also, it's a tail matters, but the tail may hurt us in this case, or the tail may help them, right, in the other one. Right. So, I mean, so that means when you talk about this tail event, so what's really important is that you want to think about, right, whether it's in your favor or it's against you. Right. So that's something I think also worth mentioning. Okay. Now let's talk about the cost. Right. The total cost of ownership, right, can be very different. The first one is that they have state-of-art servers. The server contains most of the cost. Also, they get the server interest, right? So in this case, you can imagine the interest rate is low. Nowadays, right, when the interest rate is high, then this one will increase, right? The server contains a lot of them, basically means they are powerful server. Right. Also, the server operational expense, right, and the power, those two are not very high, right? Also including the overhead. Data center, right? They also need to build a data center and with a long term of financing. Because it's a long-term financing, this interest cost is also significant, right? Even with low interest rate. And this one is that you operate the data center, right? So this is one case, the server dominates the cost. There may be other cases, right? In this one, the server only take maybe 1/3, right? But the cooling and power that take another third. And the data center infrastructure, they take it back. So this is a more balanced one. Think about it. Nowadays, right? What happened is that this server part will be more expensive, right? So for example, if you have a GPU here. But another one is that this, oh, sorry. But this part will be also much higher, the power. Right? Because with the GPU, you actually consume way much higher than the traditional one, right? Also, the interest rate is high, meaning that everything with interest also go up. So we talk about this power usage. Right? Okay, so before we talk about the data center programming model, let's do the logistics. Let me see if T finished that one. Xander, have you finished? Oh, you need some more time.
Not yet, yeah.
Okay, then let's continue with the technical part. Okay, for this one, you can say the key term here, highlight some. Okay, so first one is fault tolerance. actually. Let me highlight this one. We need a fault tolerance, right? We also need a scalability. And we also need easy access to the distributed resources, right? Then, as a result, for user who submit a job, right, to those programming models, you don't need to worry about the low-level details, right? Example, right? MapReduce, right? The first successful one, right? It has 2 stages, and it's disk-based, and try to avoid networking as much as they can because network resources could be a bottleneck. So later there's a Spark, right? So it has many stages, and they go to the memory. Right? And nowadays, right, we have more. Like for example, you can use TensorFlow, PyTorch, right, for GPU. Right? The Kubernetes is another system, right, to manage the cluster, to give you the container-based system. Right. So basically, when you use a system, for example, in your first assignment, right, when you do this, using the cloud resources, right? By doing this one, you no longer need to manage each server by yourself, right? Because the either Google file system or this probably that's the Hadoop file system, or the MapReduce or Hadoop, right? So those they manage the server for you. So whether you run application on that one or others, right, that can be easily done. Right. Let me check your first assignment. Let me see what you did there. Basically, you should be able to successfully run the file system, HDFS, and also the yet another resource manager, basically to help you manage resources. Right. Then once you have those, you can start running applications on top of those. Okay. And the data center, as you may have the Linux or the Mac OS or Microsoft Windows, right? Those operating systems will manage the local resources. And what we talk about there will be some data center operating systems, right? Like methods are Yarn, and Yarn is basically what you basically encounter in your first assignment. So basically the goal of those operating systems is try to do the fair and efficient allocation of resources among multiple programming models and jobs, right? So again, it's an abstraction. So they do all the dirty work, so you don't need to worry. It's similar to on your own computer, right? You are running multiple applications at this time. For example, I'm running this PowerPoint. I have also Zoom. I may also have other the browser open, right? But I don't need to worry about how to allocate resources to each of them. Right? This is what operating system do for me. Right? Similarly, right, this data center operator, they are doing at a higher level. Right? So like methods are Yarn, right, using the Hadoop file system. They start with a simple question, right? How to run different versions of Hadoop, right? And basically allocate the resource in a fair manner. And Google, their system, the operating system is a Borg, right? So it's basically you can consider it's a cluster manager. And the goal here is a little bit different, right? They, instead of worry about the fairness, right, as the most important objective, now they worry about the utilization because they already purchased the servers there, right? Of course, we want to have a high utilization, right? You can do the calculation, right? If you can, normally data center utilization is probably only 20 to 30%, Right? If you can double that, that means you can read half the number of servers you need. Basically, everything is a proportion to that, everything else. Right? So basically, you can halve the cost of the whole data center. Right? That's a huge amount of money, right? For a large company like Google. Right? So the bulk system is to the utilization first allocator, and this is you can consider the grandfather of Kubernetes. That's widely used nowadays. I think later I have some slides go a little bit deeper into the bulk manager. And among those as we discussed, right, the key is to do the resource allocation. Right? So basically how we should divide the resources. Right? So there are different ways. Right? One is called the DRF, the dominant resource fairness. Right? Then it also has a lot of follow-up work, including my own work there. Yeah, this is a presentation. Yeah, actually, this is probably the right time. Let me see. Yeah, let's talk about this one. Right? So that hopefully after we finish this one, the team can finish doing those grouping, and then we can select this one. Okay. The challenging part is that we have probably 30 groups, if not more. Let me check the current attendance. Okay, we have 57 plus 12, 69, 69 plus 15, 84. What do we have? In the system, we only have 84. $84 divided by 3 is 28 groups. Do we have more? Oh, yes, we have 3 groups with only 2. Okay. Okay, I think we have 28 groups in total. Right. And if we do, we probably need 7 lectures to finish them. Even if we do 4 at 1, right? Okay, so that's a lot. Okay, I find the 7 days. Okay, we need to reduce the time a little bit. Okay, so later I will reduce the time accordingly. So basically, each group, you have 3 students. Right? So we will give the assignment for you to submit the paper you want to present as well, right? About the emerging technology. Wait a second. Yeah, this is a part I do want to ask your opinion. Right. So here we have 2 options. Right. we will do the presentation. So there are two type of presentation we can do. Actually, in the old days, I don't have so many groups. I can manage to do both, but now we can only do once. But for the one group, one presentation, that can be either you present a paper, or you present basically like emerging technology, like we show here. So now let's do a poll. Let me do the poll here. I think there are two. Give me 1 second. Let me see how to launch it. Yeah, previous it was very easy to launch the pool, but now it seems hard. I just didn't find it. Okay, let me explain. The paper presentation is basically you pick a particular paper, right? A research paper, not a survey, or literary review. But for technology and application, you just do the pick up one application, right? Like edge computing or edge AI, for example. So the two are very different, right? So that's why we previously did both, but now we don't have enough time to do both. We want to say the preference here. That's try to do that. I will pause it in 30 seconds. But so far, what I see is that there are some advantage in the technology application, but still a significant of students are doing the research paper. 1/3 and 2/3. Okay, I will pause it in 5 seconds. Okay, let me end the poll now. Okay. You guys can see the result, right? So we have a 50 student participate, so it's a very good coverage, right? So technology and application is favored, but there are still significant interest in doing research paper. Okay, let's do this one. So you can have two versions. You basically tell me, right, whether you are doing it for emerging technology or you are doing it for research. For example, transformer. Okay, so let's go one by one. Right. So the first one, if you do for emerging technology application, right? So basically, this is a template, right? And this one opportunity for us, we don't have so much time, maybe 3 minutes. You have and talk about the pros and cons and its application scenarios. So of course, this is just recommended template. You can adjust accordingly. But the basic you need to cover. This one is required, right? And this one is also required, right? So and you need to have two interactive non-polls and two questions to save some time. Let's do three. You have three members. Each member asks one question, and the three. So basically, you can do the math, right? So each presentation is 15 minutes, including the 3 minutes Q&A. So basically, each student, each member, you only have 4 minutes. Basically, I suggest you have no more than 4 slides. Right? So it's not a lot of work, right? But you, within the 4 slides, I do want to say you can do them well, right? And also, do not include a lot of text on your slides. Right. So for this one, it's I give a template that I have to do that. But in many other slides, right, you see here, for this one, I actually don't need to talk a lot about the, right, include a lot of text. Right? Even for text, try to organize them a little bit better. Right? Don't have the, I have some examples, right? Later I can, when you do the presentation, I can also tell you on the fly. So a lot of students, they have tons of text on the slides. I mean, even read through them will take the time longer than what you have. Right? So also, and don't go over time. Actually, if you go over time, I have to reduce your grade, right? Because you're actually taking additional time from either other lecture component or from other groups. So keep it short, but to the point. Actually, I think that is even harder than you put a lot of material in your slides and hope the reader or the audience can figure out what are the most important parts, right? But that's not the right way to go. Okay, this is for the, sorry, did I share the slide? Yeah, this is for the paper, the technology presentation. So basically you want to go through this. I think I have the other one. Give me 1 second. Let me find it for you. if you do the research paper presentation, right? This is again, 50 minutes slides. But here, because the paper is more organized, then you can divide the work like problem, motivation, ideas, right? Or solution and performing evaluation and compare to related work and your idea. And also, again, you want to talk about the values to students and minimum 3 interactive questions, right, to ask during your presentation. Basically, each member you should ask one. Let me put it here. You can have these 2 parts as well. The recommended readings and also, right, again, summarize the requirement, right? So this is required. Okay, those are the requirement. Okay. So any questions about those 2? So basically, later we give you the submission for the topic, right? Basically, you either send us the paper you select, or you let us know which application you choose. Any questions? I saw one in the chat. Okay, it's a group created by the other Brightspace. Okay, perfect. Okay, let's go to this spreadsheet. Okay, this is a spreadsheet you will see very soon, right? And yeah, so how many students? Is there any duplication? So first student, you want to look at. Okay, so probably not. Okay, so there are 3 students. Are you here in the audience? Also for group 5, group 14, and group 23. Anyone from here? So basically now, what I will do is that I will allocate these 3 students to these 3 groups, so that each group now have 3. Now let me know if you have any preference. Otherwise, I will just go one by one. I will wait for 10 seconds. Let me know any preference. It's basically like this. Okay, so now we have the groups finalized, which is a good first step. And now let's talk about the presentation date. So we will devote these 7 days, and each day, probably most of the time, to the presentation. And yeah, I can shorten the lecture part. Actually, it's good for you guys because the quiz will be a little bit easier. But my hope is that through the presentation, you can actually learn something, right? It's a good hands-on experience. And so many students, the presentation have something to improve, right? So also for the first several groups I can do for you is that we create a Google form, right? To ask all the audience, the students, to give you feedback, right? Of course, later groups, you need to do it by yourself. Okay, among those 7 days, you need to, the first one is basically next Thursday. So if you do the first one, there will be 10% bonus. If you do this one, 5%. Right? So, and if you do later, there's no bonus. Right? So actually, my experience told me doing early is better, right? Because with this one, you can easily go to almost a full mark. But the later one, it will be a little bit challenging. So what I will do is that I will copy the link and put it in bright space, right? So that you guys can start selecting the time, the date. Okay, now once we come here, so this is the topic. Of paper. You want to, once you finalize this one, put them there. Okay. So for paper, first come, first serve. You cannot select the same paper. For technology, you can. Basically, it's very interesting to see multiple groups presenting the same topic, same application. Because application, there are tons of material you can use. And so I don't see any problem. But the paper, right, it's a little bit awkward. Once one group present the paper, you have another group present it for the same paper, right? Right, so each line, each lecture, only 4 groups. Right? So, and do not overwrite those from others. Yeah, so someone edits some for okay. Okay, I received that one. The group 8 already get the September 19th slot. The group 6 don't keep editing. Again, do not edit. Yeah, someone is over. I mean, it's hard to say who is overwriting whose. Right? But yeah, this is the challenging part for collaborating, right? Because you are basically editing the same database at an asynchronous way.
Professor,
Mhm.
this is from Krishna from Group 6. We have been edited this at the starting itself, but I don't know how our number has been changing.
Yes, let me check that. If there is a history. So we can say who did that. But how to say that? Oh. So anyone who realized there is a completion, let me know. That I can say from my part. Okay, so from history, it's actually go to say group 6. Actually, it's the other way. Right? So it's a group 8. You delete 6. So you can see clearly the record shows you replace 8 with 6. Okay, any others? What challenge is that?
Professor, we just wanted to confirm your group 27. I just kept under September 19th group 4 division. I just wanted to confirm that. Yeah.
Let's check this one.
Yeah. I edited that first, but someone edited after me. I'm Sri Datta, by the way.
So original 19, deleted 19, added
I first
20.
edited to 27 and someone edited to 17. Yeah.
Yes, so this one go to 27 in that
Yeah.
sense.
Thanks, Professor.
So we will say that it give history who replaced who. Right. So, okay. Any other one who has a conflict? Yeah, if you have a complaint about some of the group 2, September, this one, right? Let's see the history here. The first one got this one is 16. Yes, 16, group 16, do you need the group 2 on September 19th?
Yes, Professor.
Yeah, go ahead.
Thank you.
So
Thank you
this
so
one,
much.
yeah, that is 16.
Okay.
Group 3, September 19, group 3, yeah, this is the one. That's the history.
Professor Moni Sayana Gayatri is from group 8, Professor. This one.
Okay, so you added 8,
Sorry,
replace
Professor.
8 with 6. Yeah, this one should go to, sorry, should go to group 8, right? So
Yes,
September
Professor.
19,
Yes.
group 3, and group 6, right? You see the history shows that you replace, at least from what I see here, the history shows. Right, and then we replace. So basically means that should be 8. And September 26, group 3, this one. Okay, this one. The first one added group 16. But group 16, you already have one. Okay, you probably move there. Let's say the next one is 21. Yeah, 21 get this one. And you deleted the 6. But you deleted it, your 21. 21, let me see. Group 21. Yeah, your own member deleted it. So the next one who put in group 6. But you also deleted the group 6. Let me see if it's your own member. No, it's someone else. You deleted the others. Added your own 23. And that shouldn't happen. Let me say, group 6, do you want to have the 3rd spot on September 26th?
Yeah, okay, Professor. Will take it.
This should be group 6. Group 23, actually you are deleting others and put your own. So that's what the history shows. So that's why I'm giving this back. Basically, you say the group 6, they first added, and then you deleted the member from group 23, deleted it, and then added your number. But you shouldn't do that. Oh, okay. For the bonus, it seems that, okay, I can tell you. What happened is that there will be a cap on the, let me check the syllabus. What is the total score on this one? The presentation has 10%. Right? So that the highest score you can get is basically 10. Right? So, but for the presentation on the first day, right? If you get 9.1 higher than that, you directly get to 10. But even you get 9.5, it's still you get 10. Right? It's just you go to the highest one. But for other group, right? You basically can learn from the previous groups, right? So that you can do better. So, I mean, we won't give you additional work, but it's just do your presentation, prepare that as good as you can, and then you are likely to get a very good score. And also, in order to get a score larger than 9 out of 10 in the presentation, right? Normally, as long as you put in enough effort, so it's clearly to see, right? Some groups, I think I give the score lower than 9 because you can easily see that they don't know the material, that they just read the slides, and the interaction is very limited. There must be some reason, right, for you to get a low score. So my suggestion is that for the full group on the first day, because you have no experience to learn, right? So yeah, that's why you get the bonus. But for those who present during the October, you already see 8 groups presenting, right? So you should be able to do better, basically. Right? So I think it's fair. It's just for those who do better, we want to compensate them. Otherwise, right? So later groups can take advantage of those who go first. But yes, from the result, I do say that especially for group presenting on the first day, they are likely to do better. But that's because later groups, some groups, are not putting in enough effort. It's possible that those who do first actually put more effort. For example, now we probably still have 2 groups, have nobody here, right? So there are no one selecting the slot for them, right? Then you can imagine, right, their score might be challenging, right? So let's say, so TA, can you check which groups are not there and just put them on the last slot, right? So normally that's what I say, right? But for those who don't get the first 8 slots, don't worry, right? So as long as you do the decent work, you can still get a fairly good score, right? And meanwhile, besides the presentation, what's more important for your final grading is probably the quiz, right? Which you will do the first quiz next Tuesday, right? And again, it's in person, right? For the students who are not here and maybe some of them miss it, if you miss one, you lose 10 points from that. And to help you a little bit, let me actually show you what we did for last year. Okay, so this is what we did. Of course, the material covered is slightly different, right? Because now, last year, we only have 2 quizzes. So basically, it's cover more. But you can see the style, right? And you can also test yourself, right? For the part you already learned, right? Whether you can answer the question correctly. The first one, let me take a screenshot. Okay, the first one is the primary difference a public cloud from private cloud, right? The public cloud is owned by a single organization, right? They can be the same for both private and public, but the public can be accessed by multi-tenant in a pay-as-you-go manner, right? While the private cloud is normally not the case, right? It's used by a single organization and it's not a pay-as-you-go, like a Google engineering using Google Cloud, right? Then you just use it. And the public cloud resources cannot be accessed over the internet, right? Of course you can. And it's only used for storage. You can use for multiple things, right? So that's why the answer of the first question is B. Second, Google Cloud Platform, right? It's an example of a public cloud, right? Basically, inside Google, they have a different way to manage resource they can use. But it's a Google Cloud, or I can ask you Amazon Azure, or I can ask you, Amazon AWS or Microsoft Azure is also an example of a public cloud. Now, this is which factor is not a main contributor of the recent research of AI intelligence, right? AI, right? So we discussed in the class, right? So you have a you have a larger data set, right? You have the neural network. Probably this is not the final version. You have more processing power in modern GPUs, right? But the 5G is not one. Actually, compared to 4G, for 5G, we still know what is the key advantage. Other than it's a little bit faster. So there are other questions. For example, which of following could typically not be found inside the data center, right? So this is also easy, right? It's a user interface monitor. That's not. But you have a cooling, you have a backup, or you have network switch. Also, to describe a data center, this is it's not a cloud storage, right? It's not a high performance personal computer, not an individual rack, but this is what it means. Okay, so there are some not covered, but some of the, you can basically see the style of the question. If the first quiz, especially, we hope we didn't make it very hard, but as we go, it might be a little bit, I'm not sure. Let's see how it goes for the first one. Okay, so next part. Let me go and create, the TA just told me now we have the groups there. Let me create a new assignment. Because the first presentation will be next Thursday. By next Tuesday, you need to submit the paper. For both of them, you need to submit why you pick this. And they should be related to your project. So I know you don't have a very concrete project idea yet, which we will do that in roughly 2 weeks. But we need this along the line that you do your project, right? Otherwise, you waste the opportunity that to use it to help your project. Let me make it visible. Submission. Let me do the group submission. And let me check the question. Necessary for the course project. Yes, I think this answers your question. Yeah. In some rare cases, you can change later. For example, you pick a very challenging topic, but later you realize that it's too much, right? We can adjust with some discussion. But that will definitely hurt your performance and your final score, right? Therefore, I suggest you from the beginning, right, think carefully about what delivery you can do and the topic, right? The topic, right? Once you select the topic, because I mean, look at the date, right? So the proposal will be already in the 5th week, right? Basically after proposal, you will find a presentation, you will submit your proposal. So that will be, you use 5 weeks to pick a topic, right? Because from the first lecture, I'm asking you to do that. You use more than 4 weeks to do that, right? Hopefully you don't have to change it later, right? Because you actually don't have so many weeks, right? Before your final presentation, right? Total, we have 15 weeks, right? But the last week is for presentation. So you basically have 10 weeks to work on that, right? So I think it's reasonable to pick the topic by the end of the 5th week and don't change it. Right? Especially the high level direction, right? You probably want to decide that as soon as possible, right? Don't just wander around among many different topics. Right? To finalize that, and also during your proposal presentation on September the 24th, I have the opportunity to give you some feedback, right? If I say there something goes wrong, right? And also for the office hour after that, right, we can also discuss, right? So, but you need to have your own idea as soon as possible. Otherwise, right, if you keep waiting, then you will have some disadvantage. Okay, now let me give the assignment. Okay, any other questions before we stop? And for the quiz, that will be until this slide, 16. And later I will upload the slides. Also, the Tuesday class, you are supposed to be there in person, right? Even for those who select the online one, because the online is just to accommodate the data science student, right? We send you several emails, ask you to enroll as soon as possible, but some students still didn't do that. So in the end of the day, other students have already enrolled in the class. So we have to create that online section. Otherwise, you cannot graduate, right? But you should be there. And so I cannot guarantee that every time there is a video recording, right? Or there may be some technical issue there, right? So also we have this, right, on Tuesday, as we say. Also a reminder, assignment 1 is due tonight. If you haven't finished, right, try to do that. And I saw some questions in the Piazza, and both Sander and Yunlong is good. It would be great if you can take a look and answer them as you see fit. Okay, any other questions? Okay, if no, I will stop here, and I will see you guys next Tuesday, and also we will do our first quiz there. Yeah. Question like whether we can extend the deadline, may or may not. Try our best first. Okay, see you next Tuesday.